Hello everybody, I'm Valentina from Cero Trade. We are a team of 3 Latin Americans, our CEO Joaquin Gonzalez, CTO Valentina Levitz, and Adrian Palencia, our tech lead. We leverage over 10 years with blockchain experience. We are sustainability experts and we have expertise in design thinking, and we love our continents. So we're building a marketplace for tokenized climate assets in LATAM, starting with renewable energy certificates or IRECs, and our platform allows companies to trade climate assets in a secure and transparent way. Did you know that in Latin America it takes over 30 days to close just one environmental asset transaction? But first, what are environmental assets? So companies that aim to go green must first calculate their carbon footprint, reduce it as much as possible, and then compensate for what they can't reduce by investing in green projects via carbon credits or renewable energy certificates. This is a big deal in Latin America, not only because we foster over 47% of all forest areas in the world, but because in 2020, many Latin American countries actually produce more than 50% of their electricity from renewable energy resources. However, this is how these assets are being sold right now. Via email, there's no standardized market, and this is very confusing for the companies. And because of this lack of trust, companies will implement complex internal security measures that make the payment process take about 30 days. But our customers actually are the traders that must wait for these transactions, dealing with cash flow issues and high bank fees due to currency exchange between Latin American countries. We are looking to reduce the time from redemption to payment from 30 days to 15 to 30 minutes, reducing costs from international transactions by 29%. How are we going to do this, you ask? Via blockchain tokenization. We will enable cross-currency trading, reducing costs, using a custodial model to secure asset custody until payment is confirmed, and we will automate key processes with instant KYC, contract generation, and error prevention. How big is this problem, you ask? Pretty big. The IREC protocol market size is $8 billion, the IREC market size in Latin America is 74 million, and the IREC market size in our operative zone is 45 million. We're Cero Trade, where being green is made easy. Now it is time to check out our MVP demo. Why did we choose ICP? Well, because of its scalability, efficient canister creation, and token management. Despite initial challenges with costly HTTP calls for external APIs, especially the Evident API that we use to manage the IRECs, we've optimized performance and now testing our MVP with users while pursuing regulatory approval. So here first we have logged in. We'll try to import some IRECs. There it is. You can check it out in our portfolio. We access the token details and we'll try to put some for sale. So we put 1 megawatt hour for sale to 0.01 ICPs, and you can check it out in the marketplace. There it is. So we go back to the token detail view and we'll try to redeem this token immediately. So we choose the dates for the redemption, the language of the certificate, and the beneficiary. We have already added this beneficiary before, so we will log in into the account of the beneficiary and we will try to accept the redemption request. There you can see you have different requests. We can dismiss the ones that are not valid anymore, and we can accept the redemption request. So now that it is accepted, the beneficiary has paid for the redemption, and we can go to their transactions and look at the redemption that is made right there, and the block already saved. Let's talk architecture a bit with this component UML diagram. The user connects to the app through the front end, which is in a Vite app in the front end canister, and every HTTP call is made through our HTTP service canister, which connects to our own API that has its own layers of security. The API is in a Docker container, and it is used mainly to store some sensitive data we do not want in the blockchain, and to connect to the Evident API, which is the organization that administrates all of the IRECs emitted worldwide. Regarding canisters, we created a complex system of directories that allow us to dynamically create and map our canisters, so transactions, notifications, users, canisters, and any other canister that will indefinitely be growing in size has their index counterpart. So tokens or IRECs and users are stored in one canister each for maximum scalability. And on the other hand, the agent canister handles all inter-canister calls, and all the HTTP calls are handled by the HTTP service canister. So finally, regarding code, First, we have the dynamic canister creation, where we use one canister per asset or IREC and one canister per user. This is because in order to integrate with the ICRC token standard, we need to have one canister per token because it needs one principal for each token. And to register new users, it's because user information can grow indefinitely, so it's better for scalability to have one user per canister. However, it's important to keep in mind that creating canisters is costly, so if you are under attack, you have to be careful that that can be quite expensive. It works the same for the two cases. I will just show you the one for the tokens. So when a new asset is imported into a platform, the system checks if the asset is already registered in the token directory, and if not, it creates a new canister, installs the necessary WASM code, and registers the token in the directory. The same happens for users. Then we also create new canisters every time that an index canister is full. So when an index canister becomes full, a new one is dynamically created and the mapping in the hash map is updated. Here you can see in the code how that is done. The function recursively checks whether existing canisters have enough memory to store new transactions, for example, and if no canister has sufficient memory, a new one is created dynamically. In the third place, we have the HTTP integration for external service communication. We found that it was quite a bit of code to do HTTP calls, so we decided to have just one canister handle it in order to minimize the amount of code that needed to be repeated. So in the end, we just created these functions, one for each type of call, so one for post, one for get, etc., etc. So here now we have the ICRC token management, so for minting, burning, and transfer. And this is pretty standard. You can look it up in the documentation, but it's important to note that you have to import the canister corresponding to the ICRC standard and the methods that you want to use in order to be able to communicate with it. Thank you very much. We are Cero Trade, and this has been our final milestone presentation for our ICP Developer Grant.